Hello everybody, my name is Jillian Woman Yi and our group will be presenting to you static in real life. We chose laptop as our example. Laptop is a very common electronic device that can be found in almost every household. To surf the internet, working from home, online learning, and also to keep up with the news, which is very crucial for the time being. And I wonder, where the static occurs on the laptop? Let's find out. We have 3 objectives to convey in this case study. First, to analyze systems using free body diagram method, which can be done by drawing the free body diagram of the laptop. Next, to use equilibrium-based analysis for various structures, which is the calculation of the equilibrium force when opening the laptop. Lastly, to employ moment of inertia-based analysis for problem solving. There are 3 simple steps for our methodology, which is first, the initial state of the laptop, screen down. Next, I use both my hands to open the laptop. So right hand on the screen of the laptop and left hand on the base of the laptop, which means that I have inserted force when opening the laptop. Lastly, the screen stays open and I can use it. So the dimension of the laptop has been tabulated as the following: height of 22.8 cm, width of 30.41 cm, depth of 1.56 cm, and lastly, the weight of the laptop is 1.25 kg. I will leave the calculation to the next member.
Assalamualaikum, I am Afi and I will present about the LO1, which is to analyze system using free body diagram. So for our case, we are going to do the opening of the laptop. We need to know first that laptop can be divided into 2 parts, which are the screen and the base. So this is the free body diagram of the laptop. As you can see, there is an F2 here, F2 force acting here. There is reaction force acting upwards and weight force acting downwards. There is a friction force here, and there is F force here acting on the screen of the laptop. So the F force can be resolved into Fx and Fy. So this is the free body diagram of the laptop when it is not separated. But in order for us to determine the internal forces of the laptop, we need to separate it. So these are the two free body diagrams of the laptop and it is separated. So the above one is the free body diagram of the screen of the laptop, and the second one is the free body diagram of the base of the laptop. As you can see, there are internal forces acting on it, which are the AX and AY. So we decided to put our F2 here and F here. As you can see, when we are going to open the laptop, we should put force on the screen of the laptop. But we decided to add F2 here to make sure that the laptop will not tilted or move when we are open the laptop. So next will be the LO2.
Hi, I'm Junchen. Now I'm going to discuss about LO2, which is just equilibrium-based analysis for various structure. So when the laptop is in equilibrium, the summation Fx and summation Fy and the summation of the moment in the system are equal to 0. Based on this free body diagram, we can see that there are 2 forces exerted on the x-axis, which are the Fx in the negative direction and the frictional force in the positive direction. So when the summation of Fx equals to 0, we can say that 0 equals to negative F cos 45, which represents the Fx plus the frictional force. Through this equation, we will find that the frictional force is equal to the Fx. For the y-axis, there are 4 forces exerted on each, which are the Fy in the positive direction, normal force in the positive direction, weight in the negative direction, and the F2 in the negative direction. So, when the summation of Fy is equal to 0, 0 also equals to F sin 45, which represents the Fy plus the normal force minus the weight and minus the F2. After substituting the value, we will find that normal force equals to 32.26 minus F sin 45. Now, I'm going to find the moment at point A. The formula of the moment is force times with the perpendicular distance to the point. There are a few forces have perpendicular distance to point A in this system. For example, the normal force with a distance of 11.82 cm, the weight with a distance of 11.82 cm, F2 with a distance of 5.31 cm, Fx with a distance of 21.24 cm, and the Fy with a distance of 22.8 cm. Due to the normal force and the Fy will rotate clockwise to point A, the values of these forces will be negative. Weight, F2 and Fx have positive value as they rotate in counterclockwise direction to point A. After substituting the n as 22.26 minus F sin 45 and the value of weight and the F2, we were able to get the value of F. Through calculation, we find that F equals to 8.97 Newton. Now we have the value of F, we can find the frictional force. As mentioned before, frictional force equals to F cos 45. By substituting F equals to 8.97, we will find that frictional force equals to 6.34 Newton. About the normal force equals to 22.26 minus F sin 45. Now we know the value of F and substitute F equals to 8.97, we find that normal force equal to 15.92 Newton. So, when the laptop is in equilibrium, F equals to 8.97 Newton, the normal force equal to 15.91 Newton, and the frictional force equal to 6.34 Newton. Now, we can find the internal forces. There are two forces exerted on the y-axis, which are the Fy and the Ay. Both of these forces has exerted in the positive direction. When the summation of Fy equals to 0, 0 also equals to F sin 45, which represents the Fy plus Ay. Through this equation, we can say that Ay equals to negative F sin 45. By substituting the value of F, we can find that Ay equals to negative 6.34 Newton. There are two forces exerted at the x-axis, which are the Fx in the negative direction and the Ax in the positive direction. When the summation of Fx equals to 0, 0 also equals to negative F cos 45 plus Ax. Through this equation, we can say that Ax equal to F cos 45, and substituting the value of F, we will find that Ax equal to 6.34 Newton.
Hi and hello everyone, my name is Untitled. Today I'm going to present on how to calculate the centroid of the laptop. As we know, laptop is formed by two shapes, which is the vertical shape, vertical rectangle, and the horizontal rectangle. And we should also put the axis, which is the y-axis and the x-axis, so that we can easily know where the centroid is. Okay, for the next slide, we need to separate each of the shape so we can know the area, the x bar, y bar, x bar A and y bar A. For the area of vertical rectangle, we get 4.248, which is 21.24 times by 0.2, so we get the area. For the x bar, we know the width of the vertical is 0.2, so we divide by 2, we get 0.1. For the y bar, 21.24, we divide by 2, we get 10.62. But we should plus the 1.56 because we need to consider y-axis from 0. For the x bar A, we area times by the x bar, 4.248, we times by 0.1, we get 0.4248. For the y bar A, we get 51.7406. For the horizontal rectangle, the area is 33.1344, which is 21.24, we times by 1.56, so we get the area. For the x bar, we can easily divide the length of the horizontal rectangle, which is 21.24, divide by 2, we get 10.62. For the y bar, 1.56, we divide by 2, we get 0.78. So for the x by A, we just easily multiply each other. X bar multiplied by A, we get 351.8873. Y bar A, we get 25.8448. So after that, we plus off all this, so we can get the total of x bar A, which is 352.3121. And for the y bar A, we get 77.5854. For the area, the total is 37.3824. Okay, now we know all the components, so we can know the centroid. For the x bar is equal to total of x bar A divided by x A divided by the total of area, which is 352.3121 divided by 37.3824. So we get 9.4257. For the y bar, is equal to the total of y bar A is divided by total area, so we get 2. So the centroid of the laptop is approximately at this area, 9.4 and 2. So that's it, the step on how to calculate the centroid of the laptop. Thank you.
Hi, I'm Gyration. So continue to moment of inertia. We will calculate moment of inertia with respect to x-axis. First, I would like to introduce formula used in here, parallel axis theorem. It can be used to find moment of inertia when it is not touching the x-axis. So A is the area of rectangle, D is the perpendicular distance between centroid of rectangle to x-axis, just like the D in the diagram here, and B is the length, and H is the height. And the formula below is a formula that used to calculate rectangle that touch the x-axis. So this is the calculation. For vertical rectangle, parallel axis theorem is used since it is not touching the x-axis. So we just insert all the values that we found, and this 789.9037 cm to the power of 4 is the moment of inertia of vertical rectangle with respect to x-axis. And for horizontal rectangle, we will use the second formula, which is I is equals to 1/3 BH cubed. Actually, we can also use parallel axis theorem too, because it has D, but since it is touched to the x-axis, it is easier for us to use this formula. We will get the same answer, which is 26.8786 cm to the power of 4. So the summation of moment of inertia with respect to x-axis will of course be the sum of both answers we get just now. Just sum it up and we will get 816.7823 cm to the power of 4. And the last one, to find the radius of gyration, we need to use the total moment of inertia with respect to x-axis, which is the value that we calculated just now, to divide the total area, which can be found in the previous when calculating centroid, and then square root for this answer, and we will get 4.6743 cm. So in conclusion, we managed to demonstrate all three learning outcomes, which is the first one, analyzing systems using free body diagrams. Second, use equilibrium-based analysis for various structures. And the last one is employing moment of inertia-based analysis for problem solving. Statics is around us in our real life, and laptop is just one of the examples. So why don't you try to find it out?